Well, welcome. I wanted to talk to you a little bit about what is a microcontroller and what is Arduino, and I know all this can sound a little bit daunting, but it's really actually pretty simple. This here is a microcontroller. It's the Atmel 168P. It runs at 16 megahertz, which is 16 times the speed of the first 8-bit Apple computers. Those ran at 1 megahertz, so this is 16 times faster. But by itself, it's not very useful. It requires some components to really be accessible. So one of the first real innovations that we seen in the hobby market was the development of this Arduino board. So the Arduino board, it does some interesting things. First of all, there's a voltage regulator on it, so it can run on a wide variety of power. So you can usually run these between 5 and 20 volts, which means you can take any number of different wall warts. As long as they'll plug into this thing, they'll generally power it. And as this is plugged in, you can see that this little LED here starts to blink. It's tied to pin 13 on this controller. These controllers have about 20 digital inputs and outputs. So each of those 20 pins can operate as either an input or an output under software control. So you have to go in and program them to tell them what they're going to be when they grow up. But on pin 13, they've tied this little LED here. So you sort of have this test LED on the board, and you can see what's happening. So this is running the Blink sketch, which is the basic sketch that's uploaded to these when they come from the factory. You can also power these from a little 9-volt battery. So here I've got a 9-volt battery and a little adapter. And you can see here, similarly, this little light starts to blink. This is a genuine Arduino. So it was actually from the Arduino Foundation. But since these are open source and anybody can make them, here's an example of a Chinese-made, inexpensive Arduino Uno compatible device. These are probably the most popular Arduinos that you find on the market. I really like these little Pro Micros, or the Arduino Micros. They run on a USB micro connector instead of the Type B connector that you see here. They're a little more compact, and so they fit into projects quite easily. They've got a flat pack or a surface mount microcontroller instead of the dual inline pin controller here, but they work similarly. So if I were to plug this one in here, you'll see it starts to blink. So this is running basic sketch on it, that the standard blink sketch. But I can go in under software control. I'm going to go into the Arduino software here. I'm going to upload a different sketch. It just takes a second to upload. And you'll see here, now it's just on. Or I could come in and launch a sketch that's what I call the blink fast sketch. So instead of running at 1,000 milliseconds or 1 second per blink, here you've got only 250 milliseconds. So this theoretically blinks 4 times faster. So the other thing is, you'll notice on this particular Arduino, it has these series of pins on the bottom. These are called header pins. They're also called DuPont connectors. And so the first thing in our project that we're going to do is I'm going to install some DuPont connectors. Instead of on the bottom side of this Arduino, I'm going to connect them to the top side, because I think it's going to be a little bit easier to use those in a project. When you purchase these, they usually come with a couple of these little DuPont connectors like this. Now, I happen to have a large collection of those. You can get them in a kit like this. They have a bunch of these. These just break apart into be, however many that you want, if you just want 1 or 2. And then they have matching sort of connectors that go into those. But for this one, I'm going to go ahead and attach these just so you can see how it's done. So typically what I'll do is I'll put these on the top like this, plug them in, I flip it over, and I plug it into a breadboard. And that gives me just a little bit, push this down in here, that'll hold it securely while I'm soldering. So what I'll do to get this connected is take a little bit of solder, it doesn't take very much, and I'll just start to work down the row here, just like that. And I just wanted to do this so you get the idea that it's not really complicated. In fact, I find it to be quite therapeutic. Just like to blow the smoke out of the way, because otherwise it gets up your nose. But what we're going to do after I get this all soldered up is I'm going to load those 3 basic sketches on there. Just the on sketch, and then the blink sketch and the blink fast sketch. And we'll just test this guy and make sure it's working the way that we expect it to work. Why would you mount these upside down like this? Well, if you're going to mount this in a project container, which you can do by hot gluing it to the bottom of a container, or some containers have little clips that you can clip these into, then it'll just allows you to sort of fasten it in there a little easier. So, you know, I just want to show you there's not just one way to do this. There's maybe a couple different ways to do this. So there you go. Just took under a couple minutes. And we've got both of those headers are soldered on there securely. So they don't seem like they're going to go anywhere. They're on there, oh, kind of straight. These are going to require a little bit of straightening, but I'm going to go ahead and connect this up to our Arduino software. Let it register. So it's got the blink software on there. I'm going to go ahead and load the on software. Just take a second. And there it comes on, and it'll stay on steady. I'll load the blink fast sketch. And you'll see it blinking quickly. And now I'm just going to load the blink sketch. And you'll see the typical blink. And really that's all there is to it. So it's just a brief introduction onto what Arduino is and what microcontrollers are. We're going to use a microcontroller like this to build the macro pad for my computer. So I thought you might find all that to be interesting. Thanks for taking the time today.